consists of different types of attributes protected, which is represented by a hashtag, and public attributes, which is represented by plus symbol, and once again protected attribute and private and packaged attribute, like that. Next, absence of visibility marker indicates as public visibility. That means if we remove these visibility markers, if we remove this visibility markers, that means plus, minus, hash, if we remove all these things, then what we have to think is every attribute and every operation as a public attribute and operation only. That means if I remove this hash symbol here, if I remove this hash symbol here, that means nothing is there before this check orphans. Assume that there is nothing is there. Then what I have to think, this attribute or operation is a public attribute or public operation. Similarly, if I remove this entire thing, this minus symbol and as well as the private representation, then also I have to think that this compact attribute or operation as a public kind of a thing. That's what I have represented. Absence of visibility marker indicates as public visibility. Next, instance and static scope. It represents a value in each instance or value shared by all instances of the classifier. Let us see the meaning of this one. 522, 20 lateral entry student, you have raised your hand. Any problem? Roll number 522. I don't know your name. What happened? Roll number 522. Who are you? Okay. I think it's by mistake. Right? Okay. Instance. It holds its own value for a feature. It holds its own value for a feature. Static scope is just one value for the feature for all instances denoted by underlying the feature string. If you see here a representation, header is a attribute which is said to be as frame header, and unique ID, which is a long. The difference between instance and a static scope is, see the definition of a static scope here. It is just one value of the feature for all instances. It is just one value of the feature for all instances. For example, a particular student is there. Particular student is there. That student consists of a name, roll number, address, and marks, and gender, and so on. Consider these are the 5 properties which a student is possessing. According to the definition of static scope, it's just one value of the feature for all instances. Name consists of one instance. Name can be anything like Ravi, Chandan, Suresh, Sunil, whatever it may be. For example, the name is Sunil. The name is Sunil. And address is like Gachibowli. Address is like Gachibowli, and the marks as 100, and gender is male. What a static scope defines is of the feature for all instances. This is one instance, and gender is Gachibowli is another instance. Marks 100 is another instance, and gender male is another instance. Of course, roll number is also one instance. For example, consider another student is there with the name called same Sunil, and address is also Gachibowli, and the marks is also 100, and the gender is also male. But how we can differ those two students by basing on this roll number only? By basing on this roll number only, I can differ two or more students who consist of or who is possessing with same name, same address, same marks, and same gender. So, what is static scope defines is it just one value of the feature for all instances. Here, roll number is considered to be a static scope. By basing on this roll number only, I am differing all the other instances. That is the meaning of static scope. Next, what is an instance? It holds its own value for a feature. Here, name is a feature, address is a feature, gender is a feature, marks is a feature, roll number is a feature. If we give any value for this name, for this feature, then it is called as an instance. That is difference between an instance and a static scope. Next, abstract class. So one bigger diagram is given here. Does not have direct instances. That is not instantiated. What is the meaning of instantiation? I think you have studied about this word in your PPS and as well as the data structures. That is in the first semester of your first year and second semester of the first year. What is the meaning of instantiation? Can anyone let me know? Who is there? Let me see. Instantiation. Lavan, instantiation అంటే ఏంటి? Object creation. Any other answer? Nitya, what do you mean by instantiation? I think it is not object creation. Mukul, Nitya, Lavan. Sridhar, that is
So it's the
Lakshmi.
creation of instance.
Instantiation, creation, not creation of instance. That means you people are saying about that means interpreting the meaning of that instantiation like you're saying the part called instance, right? That's why you're explaining like that. Instantiation is nothing but initialization. Initialization and instantiation are both the same things. For example, int a is equal to 10. That is called initialization and as well as instantiation. Instantiation and as well as initialization both are one and the same. Here, if you see this diagram, it does not have direct instances. That is not instantiated. That means not initialized. Here, how many classes are there? Four classes are there. Icon, rectangular icon, button, and OK button. If you see the basical relationships in between these four classes, OK button can be generalized as a button. Button can be generalized as a rectangular icon. That means button will be in the form of a rectangular icon, and a rectangular icon will be generalized as a icon, like that. OK button can be generalized as button. Button can be generalized as rectangular icon. Rectangular icon can be generalized as icon, like that. So origin, this is the attribute, and what I have represented here as abstract polymorphic operation. Uh, okay, we will see in the coming lines or coming notes. Rectangular icon and OK button are considered to be as polymorphic operations. And sorry, okay, let us see the theory first. Abstract class must have descendants or subclasses. Abstract class must have descendants or subclasses. So the topmost class is considered to be as an abstract class. The topmost class is considered to be as an abstract class which have these three descendants. Next, abstract leaf class is useless. Abstract leaf class is useless. That means this is the abstract leaf class because it has no descendants and no children, so it is considered as a useless class. It is considered as a useless class. Next, concrete class has direct instances. Concrete class has direct instances. Here, button and button, I'm saying it as concrete classes. Button and direct okay button, and I'm naming it as concrete classes. What is a concrete class? Concrete class has direct what I mean, or how I can define about concrete class. I think I missed something in the diagram. Concrete operations can be implemented once and can be used the same way across all the subclasses. Here the definition is given. Concrete operations can be implemented once and can be used the same way across all the subclasses. That means if you consider the button, for example, a switch is there. A switch is there on the in this switchboard or on this switchboard which is connected to a wall of your home. That particular switch can be used in the same way. And that means, for example, you use your hand to switch on that switch. Okay, there is no other way in using that switch, right? That is the meaning of concrete class. Concrete operations can be implemented once and can be used the same way across all the subclasses. That means only a single way exists in order to use that particular switch. That is an example which I am saying. And abstract class may have concrete operations, and a concrete class may not have abstract operations. Abstract class may have concrete operations, and a concrete class may not have abstract operations. So, abstract class may have concrete operations. Abstract class, what about abstract class may have concrete operations? Concrete operations in the sense only a single way exists in order to use that particular class. Okay, but concrete class may not have abstract operations. The reverse is not possible. Next, leaf classes are considered to be as the class with no children. Polymorphic operation. Here, rectangular icon and OK button, I'm saying it as polymorphic operations. What do you mean by polymorphic operation? We can specify operations with the same signature at different points. We can specify operations with the same signature at different points. For example, if you consider the rectangular icon, I'm saying it as a polymorphic operation. Polymorphic operation, what it defines, we can specify the operation with the same signature. So a rectangle will be a rectangle at all the time. A rectangle will be a rectangle at all the time. Similarly, OK button. If a button is named as OK, if a button is named as OK, then there is no other way in order to represent or replace that the name of that OK. Okay, that means if we are changing the name OK to not OK, then the entire representation or the entire operation of the system changes. Polymorphic operation, what it says is we can specify operations with the same signature at different points. According to the definition, a rectangle will be a rectangle and OK will be OK. That's all. Next, multiplicity. What do you mean by multiplicity? The number of instances a class may have is called its multiplicity. Specifies the range of allowable cardinalities an entity is allowed to assume. For example, control rod and network control. Control rod, I am saying that there are three control rods are there. That means I am representing it with a multiplicity representation. And this entire class, network controller and as well as the console part, can be given as 2 to many. That means the minimum number of this entire classes is 2, and the number will go up to infinite. But whereas control rod is a single entity, but sorry, this class is a single entity. Inside this class, a control rod is present, and this control rod is of three numbers. Network controller is a one number, and in this class another component is also there, that is console part. This network controller and as well as the control part can be in two numbers, and the list will go on increasing up to whatever the number which we assign. But whereas this control rod is only in three numbers, that is the multiplicity representation. Next, in UML, multiplicity applies to attributes also. In UML, multiplicity applies to attributes also. Next, attributes. We can model a class at the most abstract level by writing the attribute name. The properties of a class is nothing but the attributes. Additional information on attributes. Additional information on attributes requires various advanced features like visibility, scope, multiplicity, type, initial value, and changeability of attributes. So an attribute can be represented with these six properties: visibilities, scope, multiplicity, type, initial value, changeability of attributes. And we will see the explanation of each and everything, the explanation of these six properties in the next class. Okay, I'm stopping the class here, and I will explain about the features of the attributes like visibility, scope, multiplicity, type, initial value, and changeability of attributes in the next class. I'm stopping the class here. Thank you for attending the session.